Sing me the song of your people. Hello Internet, my name is Quentin, this is Blondihacks. It's part 2 of my big steam engine build series. We're going to finish up the frame today. Last time we made the lathe do some cray-cray things. This time the mill and the drill press are going to stretch their legs. So let's go. Cray-cray? Nobody says that anymore. Oh, jeez. Previously we did the bore and that boss at the top on the lathe, and now it's time to do the feet and some other features. Now the feet are tricky because, as you may recall, this thing does not even come close to fitting in my milling machine, and using the mill for those feet would seem like the obvious solution. So we need to do something else, and I have a crazy idea. Since I can't stand this thing up in the mill and the legs are too fragile to spin it up in the lathe, I'm going to lay it down in the mill, and I'm going to mill these feet sideways. To do that, I'm going to bring in my rotary table in the vertical orientation here, and I'm going to build a setup that uses the footstock at the other end, and I'm going to support this frame on a reference mandrel through the center, and that's going to allow me to mill the feet sideways and keep them very parallel to the top surface, and most importantly, square to that crosshead bore. So let's see how long this mandrel is going to need to be, and then I'll grab some scrap aluminum here and I'll cut a rough chunk off here on the bandsaw. This portable bandsaw table was a project I did recently on the channel that was definitely my idea, and not because 50,000 people wouldn't shut up about it. Shut up. I'm going to need the steady rest here because this mandrel will be too large to go through the spindle bore on my lathe, so I'll get this guy set up here and I'll slide the steady rest. Yeah. Problem, this bar is too big for my steady rest. It's fully retracted there and it is nowhere close to clearing those rollers. So I have some ideas though for how to work around this. So I'll start by tapping it straight here in the 3-jaw, and I'm going to put a center in one end. Even with all this stick out, it's still okay to use a center drill because there's no lateral forces to speak of on a center drill. And then I can get tail support in there. Now I haven't faced to that end yet, but I'll be coming back to that. My idea first was I'll turn this down a little ways and then maybe it will fit in the steady rest because I have a fair bit of diameter to reduce here. So if I can get it close and then set up the steady rest, we'll be good to go. I do want to face those ends because they're going to be part of the reference surfaces for this mandrel. I'm getting fairly close to my final dimension now, so I'll give the steady rest another shot here. And go ahead and slide that in there, and it's close, but nope, not gonna fit. So I have a sneaky plan B. I'm going to bring in the dead center specifically because that does not spin, and you'll see why here in a moment. So I've got some extreme high pressure lube here for the dead center, and I'll go ahead and seat that in there. And what this is going to allow me to do is face the end, and I can come in all the way down to where I'm touching that center, and I'm not going to gouge up the center because it's not spinning. Normally you face the end first so that you have a nice square face for the center drill to start on and ensure that it goes in straight. So I didn't have that luxury here, but I will at least end up with square ends. And now, to clean that up and get a decent center in there, I'm going to come in with a larger center drill. I'll ease that in and let it find the center made by the previous center drill, and then keep going until it's at the right taper for this size of center drill. And because it's a larger center drill, it completely eliminates the old one and mates up nicely with the faced surface. So the end result is just as good as if we'd done it the proper way. Then I can flip it around, and I'm going to put it in the 4-jaw now so I can dial it in. And once again, I have to tap in the far end, get that running straight. Once that end is tapped in straight, then you got to go back to the chuck end and dial that in again because it's going to have moved a little bit, and you go back and forth until everything is running straight at both ends. And then once I've got that running nice and true, then I do the same method here of small center drill, dead center, face, larger center drill. There's an old school tool that would have saved me here. It's called a half center, and that allows you to put a center in something, but the front half of the center is physically missing, hence the name, which allows you to get in all the way to the edge of the center drilled hole with the facing tool, but I don't happen to have one of those, so this little trick is a way around that. Now that I have centers in both ends and squared faces, I can bring in my turning between centers setup to finish up this bar. And this was the ultimate goal, after all, was to turn this thing between centers. And even though I couldn't use the steady wrist to create the turning between centers features, we still got it done. But now we have a new size problem. My largest drive dog for my lathe is too small for this bar, won't fit over it. So, well, I briefly considered something extremely stupid, and luckily had a moment of clarity and decided, no, I'm not ready to die today, and instead set up that dog on the mill and just bored it out a little bit larger. The theme on this entire project is all of my machine tools are a little too small for this, including all of the accessories. And now I can finish turning this between centers all the way down to my desired diameter. This needs to be an extremely close fit in the bore on the frame there, because this is going to be the reference bar for all of the subsequent operations, as you'll see. And around this time I was noticing some taper in this bar, but I just aligned my tailstock, so I'm very confident in its position. And you know, when taking heavy roughing passes, it's not unusual to have a little taper, and the taper comes out in the finishing cuts once, you know, there's less deflection and everything. So I turned it until it almost fits in that bore. It's just like a scooch too big, which is what I want. And then I flip it end for end, and I'm going to finish it down to final dimension from this end. I still have to clean up where the lathe dog was on that end. Then the final cleanup pass here is a very light one that runs all the way down the length of the bar and should bring me to final dimension. And well, remember how I said the taper was going to come out of this bar? Yeah, it didn't. So I had a couple of thou of taper in it, which I briefly tried throwing some emery paper at, but emery paper doesn't really work very well on aluminum. The paper immediately clogs up and it just makes a mess. So I started mapping out how bad the problem is here on this bar. And I've got about a thou of taper in it. Because I flipped the bar end for end, that actually halves the error in your taper. So there's a little trick for you, but I still had an issue here. If I was smart, while I was still doing my roughing cuts, I should have adjusted the tailstock at that time and not gone all the way down to final dimension, and now I don't have room to adjust my tailstock and take more cuts. Instead, I did something very inelegant that will definitely get you kicked out of machinist school. I just mapped out the bar and went to the areas that were a little too large, touched off very, very carefully on them, and just shaved down those areas one section at a time, carefully checking my measurements as I went to make sure I wasn't putting anything else undersize as I went. So these were very, very light cuts, like half thou and 1 thou passes, just in the areas where it was showing to be oversized. And I did a bunch of that, and then I managed to get the entire bar to within a few tenths of the same diameter all the way down. It was messy and inelegant, but I got there in the end. Oh, and why was my tailstock out of alignment, even though I was so sure about its position? Oh, right, I crashed into it with the carriage the other day, and I never realigned it after doing that. You think that might be related? But after that foo-fa-ra, this bar is now a very, very nice fit in there. I can just barely slide it in there, which is exactly what I want. This bar is going to allow me to reference all the other features on this casting and frankly on this engine to that crosshead bore, which is my entire strategy here. So that reference bar was a fair amount of work, but we're going to get a ton of mileage out of it, starting right here on the mill. So I'm going to set my center in the center of the rotary table there, and I'm going to hold the bar between centers here. And this is going to allow me to reference the crosshead bore to the mill. So I got to start by getting this bar dialed in. It's quite crooked vertically because I have not yet set the height on this footstock. This footstock is a match for this rotary table, same brand, same size, but it hasn't been adjusted yet. So this was a lot of fiddling and tapping in until the quill on the footstock was level and at the correct height. So I'm dialing in the top of the footstock and the top of the bar. It's a lot of fiddling back and forth to get this right, but as you can see here, I did eventually get that nice and straight. And then of course I checked it horizontally as well to make sure that my centers were in line there. So I've got it within a thou over the entire length in both dimensions, so this should now be an accurate reference, and I can slide the bar into the casting, set that bar between those centers, and now that bore is referenced to the mill. And then I'm going to clamp the flange here to the rotary table just for secureness, and that will also allow me to rotate the part around to do different features on it. There's something interesting going on at this end of the setup. This is arguably over-constrained. Over-constraint in machining setups is when you've got clamping happening on two different reference surfaces. So for example, in a vise, we always put something round on the bandsaw cut side of a part like this, because if we don't, we're going to end up with some weird compromise like this, where the two vice jaws are both trying to reference different incompatible surfaces there because they aren't parallel. And so putting the round bar in there ensures that only the one reference surface is constraining the position of the part. So back on my setup here, I've got this bar running down the center of the casting that's sitting in a center in the rotary table, but then I've also got the top face of this bore clamped to the surface of the table. Now I'm getting away with this because the bore and the top face were done in the same setup and thus are very square to each other, and the bar is just in a center. The end of the bar is not touching the face of the table. However, arguably, this is actually over-constrained. It's an interesting thought exercise. And note that arguably is an adverb and not a request for the comments. This isn't quite going to do it though, because these legs are ringing like a tuning fork, so there's no way that they are going to be self-supporting enough for machining. So this was my first idea. I put some threaded rod in there, used it like little machinist jacks with some nuts underneath to push up under the leg there to support it, and then clamped down from above. And that hopefully will secure this foot well enough for machining. The ring is certainly gone and it seems solid. You can tell how complex the setup is by the number of hand tools that are piled up next to the mill. This setup is a 6-wrencher. We do actually have to hit a dimension here for the height of this frame. Luckily there's a fairly generous tolerance on it of plus or minus 10 thou, but that's easy to do here because I can just edge find on the rotary table and then come down, and that's my length right there. The main thing is that this foot has to be machined extremely square to the crosshead bore. But new problem, I don't have the Y travel needed to reach the front edge of the foot. I can't move the setup because the rotary table has to sit in the center T-slot. However, I only need about ½ an inch, which I think I can get by dismantling the bellows on the column here on the mill, which are taking up some space and preventing the table from moving back a little further. So that did it. Imperial fist shake of victory. That was just what I needed, that little bit of extra help. And now I can get in there and start side milling this foot. I don't have enough rigidity or end mill to do this all in one pass, so I'm going to be doing multiple passes at 2 different heights here. And this was going okay, but I could feel that that foot was really vibrating. It was starting to chatter and it was getting worse, so the setup is not rigid enough. So plan B, I swapped out the threaded rod for some stacks of 1-2-3 blocks, and I wedged a pile of shims under the foot there, and then I set up some strap clamps to clamp down from above. I didn't have any way to create a fulcrum tall enough on the back of the clamps, but some threaded rod with a nut upside down did the job very nicely there, and that created a very tall strap clamp that I could use to clamp down on things from the top, and this setup was very rigid indeed. This worked great. I will say this setup was a real forearm workout. It's very heavy. There's a lot of iron and steel sitting on that mill table, and it was a real forearm workout. So tickets to next year's gun show are going to go up in price because the product is getting more valuable by the day, people. Here's another look at that standoff trick for the fulcrum on the strap clamps. I know it looks janky and wobbly, but it's actually very secure, so give this a try. It's not as secure as a stack of square somethings would be, but it actually works better than you'd think. Unfortunately, I got down to dimension and the foot didn't clean up all the way. The casting didn't have quite enough material there, unfortunately, and that's definitely not something that I did. So since there's lots of extra material here to machine anyway, I'm just grinding the top surface off of it. Damn it. Look, that was definitely the casting's fault, okay? Anyway, I was able to get it to mostly clean up by pushing deeper into my tolerance. I can go under as far as 10 thou, so I went to under 7 on the dimension, and then it mostly cleaned up, and, well, we'll just have to live with that. Then the next step is easy. I just fish my packing material out of there and spin the part 180 degrees on the table, fish my packing back in there, and machine the other foot down to the same dimension on the DRO. And that foot went very well, cleaned up very nicely, and you can see I got an excellent finish on that. Very pleased with that. But we can get a little more mileage out of this setup yet. The drawing calls for threaded holes on the sides of the crosshead bore for oilers, so I can just center up on my bar with the edge finder and then move down to where the oil holes are, and I can drill those while I'm here. And it's easy to reference the position vertically because I still have my 0 set on the rotary table position when I was measuring the length of the frame, so this is easy peasy. And for the depth, I just drilled down until we struck aluminum on this wellhead. And then I can just tap those holes. Tapped holes here are optional if you want to install oilers, or you can just have plain oil holes here, but I can't pass up the opportunity for some lovely glass oilers when this thing is done. And then once again, I can just rotate it 180 degrees and do the other oil hole. The setup is working out extremely well, I have to say. Now after that was done, I can pull it all apart and do some deburring, and you can see here how good the finish is on that. You can see some rubbing marks on the left foot there from where the end mill was doing the second pass, but the finish is outstanding. Credit for that goes to the Niagara end mill that I used for that. It really does a beautiful job on everything I throw at it. I won't really know how accurate that job is though until we do the base that it sits on. So this is the big casting for that. Once again, I'm fettling that to prepare it for machining. This is a straightforward machining job top and bottom, but like all castings, this one is slightly warped, and you never want to clamp down and machine a warped casting, otherwise the warp comes back after you unclamp it and ruins your work. So put some shims under the corner that is high and get that wobble out of it before you clamp it, and then it will stay flat after you've machined it. Now, unfortunately, once again, I don't have the reach on the y-axis here, so I had to shift the setup backwards a little bit to get access to all the areas of the casting here, and then I was able to run my end mill around here and just clean all of this up. There's really no dimensions or anything on this, it's just clean it up. And to get into some of the corners, I just played musical clamps and shuffled things around to finish things off. And if you did that right, when you flip it over, it should now have no rock in it, which means we've successfully removed the warp from the casting by shimming it before we clamp it down and machine it. Next, I used an inverted drill to just visually align the bolt pattern on the drawing to the bosses that are physically present on the casting. So I'm just tapping the casting around a little bit and running to each position on the DRO where the bolt holes are supposed to be until they all look like they're roughly visually centered on the bosses. This is never going to be perfect because cast bosses are imperfect things. My plan was then to bolt the casting down with those bolt holes, but they didn't line up with anything on the T-slots or anywhere else and couldn't be that lucky. So instead I bolted it to this fixture plate, and this was also necessary to get the position on the y-axis. I needed the casting sitting back on the table so I could reach it. I like to run an indicator over it to find the high spot so there's no surprises when I come back in with the big face mill to machine the top of this thing flat. And this Shrum Solutions Tri-Fly made short work of this, did a really beautiful job. Finish on this is excellent. And if your mill is all well set up, when you're done, you shouldn't be able to feel any transition lines between those cuts. I have a video on aligning your mill in all the different dimensions if you've got lines that you can feel here between your cutter passes. Moment of truth now, how does that sit on there? And the answer is very well, I'm happy to say. There's no rock in that. And as far as I can tell, it's straight. I won't know for sure until I have more of the engine built, but it all looks really good. Next step is this bolt pattern on the top of the boss. Now this thing is not a standard bolt circle, which really could have thrown me. So thank you, draftsperson Pat, for noting that this is not a standard 6-hole bolt pattern. The challenge here is, once again, the casting won't fit in my mill. So how am I going to drill that bolt pattern? Well, the answer starts with this giant slug of rusty steel. I'm going to make a drill template so that I can do this on the drill press, which is the only machine I have tall enough to drill these holes in this casting. So I got the inverted jaws on the 3-jaw here, and it won't fit in the larger steps, unfortunately, so I got to set it on the inner step, and we get to play Dodge the Spinning Wings of Death. Never my favorite thing. After facing that down, as is tradition, I'm going to go in with a center drill and then a series of larger and larger drills. I need to punch a very large hole in the center of this disc of steel, and it's going to be for the mandrel that goes through the casting. That reference mandrel is also going to be the reference for this drill template. As you see, I'm getting a lot of mileage out of that bar. So I went up as large as I could, and my largest drill size was where the lathe said, no more, I am not having that, and I had to give up. And go in with the boring bar to finish it up. And when I've got to the point where the hole is a very close sliding fit on my mandrel, then we are in good shape. That's exactly what I want. I can just barely slide that bar in there. So that's going to be an accurate reference from the crosshead bore. And then of course we chamfer that because chamfers are what separate us from the animals. To finish that part, I'm going to use one of the big kid tricks, and I'm going to chuck a smaller chuck in my bigger chuck. It's chuckception, if you will. And that allows me to hold it the other way from that small center bore, and then I can dial in that bore, which actually didn't need dialing in. That little chuck was surprisingly accurate. I guess I got lucky on where it was sitting there. And with that dialed in, I can now face the back side of this and finish up the features on the other side of this part. This little chuck was not expensive, and I bought it for a fixture I was going to make and didn't end up using it for that, but I found it very useful for this particular use case of holding parts that are too small in different ways on my bigger chucks. And then I'm also going to turn down the OD to match that boss on top of the casting. This is probably not strictly necessary, but I feel like it might come in handy at some point. And then of course, chamfer all those edges once again to separate us from the animals. Then to the mill to drill that weird hole pattern. So I centered it up with the coaxial indicator there, and now I can plot out the hole pattern here. I'm playing musical clamps once again. I'm drilling all the holes that I can reach and then removing one clamp at a time to get the rest. So the holes here are on a bolt circle, but they're not evenly spaced around that circle. Luckily, the drawing gives enough dimensions where you can deduce each hole position using the DRO, and you don't have to try and guess the angles on some rotary table setup. But you can see here how the holes are not the same distance there and there. Very tricky. I'm glad the drawing noted that, or I definitely would not have noticed and would have messed that up. I think the reason for that is so that the holes clear the casting features on the undersides of the boss. They clear the ribs there. But now we have to get the orientation of those holes correct. And for that, I'm going to try the surface plate. One of the holes needs to be centered on the front of the casting, but once again, there's no references for anything. So I'm referencing those flat casting sides to the surface plate with a V-block, similar to how I did on the lathe. And now I can set up the height gauge on that bar to get the center line of the casting. I measure the height of the bar, go down the radius of the bar, and there's my center line, and now I can scribe those with the height gauge. Once again, that bar is paying for itself. Those two center lines then allow me to set the drill plate down on there, and I can look down through the holes and just rotate the template until the front and back hole are both centered on that line, which is quite easy to do by eye, and this will be more than accurate enough for this. Then I just clamp that in place, and we can go over to the drill press and drill these holes. So the template is going to guide those drills into the right position no matter what they try to do, and so effectively the mill is transferring its brains over to the brawn of the drill press to keep it from doing the wrong thing. This weird bolt pattern also exists on the cylinder head and the lower cylinder and the gasket, so there's 4 separate surfaces that need this pattern, so the template was well worth making. This is a Kozo Hiraoka trick, by the way, of creating a template like this to get a high precision hole pattern out of a low precision machine like a drill press, and that worked super well. And then those holes were later opened up a little bit to clearance size, and then the clearance drills just follow those pilot holes. The pilot holes are smaller because some of the bolt patterns are tapping drill size, so the holes in the template are tapping drill size. Next up, the bolt pattern for the feet. This is less critical, but I still want to try and get it accurate. So once again, I've got it set up on the surface plate. I used a machinist jack until it was square to the plate once again, and then I was able to find the center line of my reference bar and scribe the positions based on their distance from center as shown on the drawings. Then I center punched those holes, and once again back over to the drill press. I'm going to drill these upside down so that I don't have to try and get a very long aircraft drill or make a drill extender or something, none of which I have. So I'm going to clamp it upside down, and for that I'm using a stack of 1, 2, 3 blocks with a machinist jack under the foot with, once again, one of these tall clamping setups here to clamp that securely. As you can see here, it's actually quite solid. I know it looks janky, but it's clamped down tight, and then clamps on the boss as well. Then I used a wiggler in the drill press to get my punch marks centered on the spindle. A little bit of magnification there is sufficient accuracy here, and then I can center drill those and then pilot drill and drill to final clearance size. Again, just using all of these different steps to try and squeeze as much accuracy out of a drill press as I can, since I can't do this on the mill. Now, luckily, this hole pattern is just going to be transferred to the base, so it's not that critical if these holes are off, but might as well strive for the most accuracy that we can here. And there you have it. That is the final frame structure all complete. The only thing left to do is bolt it down to the base, and I'm not going to do that until I have more of the engine parts to make sure I get the alignment right on all that. But overall, very pleased with how this is going so far, and very excited to start working on some parts that move. So stay tuned for the next video in this series for that. Thank you very much for watching, especially thank you to my patrons who make all of this possible. And until next time, stay steamy. No, that's not going to be a thing. Don't ever say that again.